Okay. Hello all. Welcome to the Hudi Community Sing for August 2023. My name is Bhavani Sudha. I'm a PMC member of the Apache Hudi. Here with me is Manish today he's joining us from Upstox. He's a lead data engineer at Upstox. And for the agenda, we'll briefly discuss the community stats and updates today. And from there, Manish will take over to discuss their experience with Apache Hudi at the foundation of data platform at Upstox. And then we can open up the floor for questions. So this is a screenshot from the Pulse Insight at GitHub. In the last 1 month, we have had about 51 authors committing to like 120 commits. And there are like 138 merged pull requests, 45 open, 28 closed, and 46 new issues. Our Slack has been growing. We have passed 3,500 Slack users, 4,400 GitHub stars, and 51 contributors who landed to the PRs this month. And 0.14.0 is on its way. It should be the RC, and the release should be anytime soon. There are new RFC claims. There has been one RFC, 72. This has been on the redesign of Hudi Spark integration. This is mostly around how to restructure the file relation of different Spark flows. For example, how MOR and Bootstrap could kind of leverage some of the read-side optimizations that Spark has to offer. Please check out the RFC and give feedback if you have any. And these are some resources to join the Hudi community. Our Slack is very active. Please drop by to say hi, or if you have any questions, feel free to ask there. And you can also meet other Hudi users who have been trying different things. And there are like plenty of channels there to discuss. You can join GitHub, like to raise issues directly. We have a mailing list that you can subscribe to by sending an empty email. And we also have docs that we always want to improve. So don't feel shy to give us a star if you like GitHub, like Hudi and in the GitHub. With that, I will hand over to Manish. Manish, take over the slides. I think you are on mute, Manish.
Yeah, thanks. I think my screen is visible now. Is it?
Yes.
Yeah. So, hello everyone. I'm Manish. I'm based out on in Bangalore, and just an introduction for my company and myself. So, basically, Upstox is a about Upstox. It's an online trading platform which offers web-based trading and allows users to trade and invest in different financial instruments like equities, derivatives, commodities, and currencies. So it's a stock brokerage platform. And we currently have 12 million plus customers, and we have different data driven products where we process around 300K requests on a per day basis. We and in data team we have built various products recently in past few months, like the search functionality in Upstock. So earlier it was a front end driven search. We have made it back end driven search using different technology like TypeSense, and obviously the data platform is completely in Apache Hudi. We have other services like chatbot, which is powered by OpenAI, and customer portfolio insights. So these are some products which we have built in our data team. About me, it's I've already, as I told you, I'm from Bangalore, acting as a data engineering lead at Upstox, and have a team of 4 developers. And this is my email to you can reach out to me over there. Moving on to uh, the data sources and the challenges we face. So, talking about the data sources, we have data sources from different variety of data sources that were coming from our data centers. So these were the orders data basically, and uh, which were directly coming from the stock exchange, which is connected to our APIs. And then we have transactional data and the user info data, which contain PII info also. So these are some data AWS hosted DBs like on Aurora and MongoDB. And then we have other data sources which are basically tells about the latency and uptime matrix of the microservices, which comes from Cloudflare, and directly it is pushed on S3. Then there are some log data which was the major chunk, and then we also capture some customer interaction data from a Mixpanel, which we directly consume from Mixpanel to for our some use cases, like where we have to build a customer 360 model using that customer interaction data. And then we have other customer support data, like the customer tickets which we get. So these also come from third party API like Freshdesk and Squad IQ. So these are some of the data sources which we are dealing, and it consists the total daily volume was around 250, between 250 to 300 GB of data. Uh, so earlier, like 1 year back, we were using some products like Hivo data. I think you might be knowing about that. So that was a self-serving no-code solution provided by the company called Hivo, but that was actually costing us a lot, and that's why our management decided to build our own in-house data team. And when I joined Upstox last year, so so at that particular time, we have done some development in the data platform, but we were facing challenges like the basic challenges like the file level upserts. So especially for the CDC files which we were getting for different tables which we wanted to sync in our data platform, like the joins which we had to do to update the records in the data platform, was costing us a lot in terms of compute. Then obviously atomicity was not possible there, and that was actually causing us data quality issues whenever the job would fail in between because of any reason. That would create a duplicate records, and then duplicate records, removing that duplicate records was not possible without any transactional system. So we had to do a lot of reloads of our data tables whenever there was a failure. Then for our transactional database, the small file issues were there. So we tried to reduce those things by using repartitioning and reducing the parallelism. But these were very use case specific, so we were not able to scale to larger extent. And we were basically trying to handle on a use case basis, but we could not make a generalized solution for this. So that was the data ingestion problems. Coming to the data consumption by the downstream, so we had multiple downstream consumers, like the reporting dashboards were there, which were consumed by on QuickSight. And then we had some facing use cases where the data would be used by our APIs, and some machine learning ML model where the data were consumed by the SageMaker. So all these had some or the other problem related to optimization of the query. So uh, uh, because of that, we had to do a lot of operational challenges, like even if we use bucketing and joins to optimize the joins, it would induce increased small file problems. So And also we were using Athena, which had certain limitations, like you cannot have more than 100 partitions on Athena. Then the timeouts on larger, when the size of the table was large, and if you have to process like 2 or 3 years of data, then in those cases the Athena would time out. So these were some basic challenges which we were facing, and we had to uh, create separate solutions for this. There was no generic solution, and obviously there was no support of for incremental queries. So generally in Athena we had to process the complete table. Like if it is a transactional table, we have to process the complete 1 year of data on a daily basis. So the Athena cost was also increasing for us on a monthly basis. So these were some of the challenges when we decided to move to Apache Hudi for our data lake. And that we decided and we started that migration on in this year in January. And then so this is our current architecture, like high level view of our current architecture. So we have kept our bronze layer, or we can say the landing zone as a parquet, and we have created two layers on top of that. That is our filter and the cleansed layer that we call as a silver layer. And finally, we had the final business level aggregated layer, where from where the we did data modeling on top of this, uh, on this layer, to directly serve the data sets to the downstream. So the final data sets would directly be connected to the QuickSight or DynamoDB in certain use cases, or the APIs will also directly consume from it. And to do that orchestration, so there were two options: either you optimize your Hudi tables in the silver layer, but again to consume from there, we were using AWS Athena, which actually did not had support for, which still did not have support for Apache Hudi incremental queries. So that's why we decided to shift our processing of our gold layer through EMR serverless itself, and and we completely removed Athena from this part. So we right now we use Athena just for some used for
Okay, Manish, um, are you able to hear me, guys? I'm trying to ping him to see if he's available in Slack. Okay, Manish is reconnecting.
Think I got disconnected in between. I'll just reshare.
Yeah, I think we lost you when you're
So,
talking about QuickSight
okay,
in the previous. Yeah,
this one.
yeah.
Yeah. So basically, I was talking about the different downstream consumers for our data lake, whereas QuickSight and say ML workflows was SageMaker. But mainly, I would like to talk about DBT and EMR, the Hudi and DBT integration. So DBT basically, I'm not sure if I've covered that.
I like
So,
no.
anyways,
I think you haven't covered that. I think you mentioned how you replaced Athena with EMR serverless for the gold table. That's
yeah,
the
yeah. So at EMR serverless we use because Athena didn't have support, does not have support for Apache Hudi yet. So we wanted to take the advantage of the incremental queries to reduce our daily processing data processed. And DBT was introduced because we wanted to make our data lake self-serving. We didn't want our BI engineers to like work on Spark and the technicalities of the optimizing of Spark code. So that's why we introduced DBT, where you can uh, write your SQL code, and that would internally be converted into a PySpark code and would run on EMR serverless or by on or any other platform where we want to uh, um, where you want to do the compute for your data. So that was the main architecture. Um, and then the solution with this solution we achieved the major pain points which we are facing, like I talked about atomicity and record level upsert. So that was given out of the box from Moody, and that was solved. For uh, facts and dimension tables, we had to decide between the type of indexing we want to use to improve the uh, upsert time for our tables. So based on the nature of the upserts, we used Bloom indexing. Depending upon if it is a transaction table or fact table, we use Bloom indexing for most of the cases. Then, as we were talking about small file handling issues, that was actually resolved again by clustering. So we also had created a uh, automated jobs which would trigger on a regular basis, like on a weekly basis, and which would cluster the tables and reduce the file sizes. So we don't have to take like additional care for that. And then the major thing was the incremental joins. So as I told you, like we had the final layer in the gold, that is the gold layer, where we had to join different tables and create a data set for the dashboards. So that was achieved by using the incremental joins, where you just process the data on a daily basis, and that would actually reduce, which was not possible via Athena. And archival mechanism. So one problem we faced was during that time was like we there were a lot of commit files, and the metadata files were created inside the Hudi metadata folder and the Hudi folder. So that was actually increasing our S3 list cost, because Athena would try to list all these files. And also during the upserts, Spark would also list those all those files and folders. So list cost was increased, but then we referred a blog which was written by the Apache Hudi community member only, and that explained about the Hudi archival mechanism. We have to do settings based on which the the commit files were archived after a certain number of commits. Then so this was about Hudi. Then about DBT tool, as I told you, it is a transformation tool, and you can also create materialized view uh, for your downstream tables. So it supports different materializations, like you can create a table or just a view. And ephemeral is nothing but you can create a CTs, and that models would basically your model will be created as CTE, the CTE which we have in SQL. And also DBT has some data out of the box data lineage. You can create the lineage of your data pipeline, like to understand the flow of the data, like which table your final data set is dependent upon different tables in your silver layer. So those dependencies you can figure out in a visualize that, and that will actually help you in during your debugging, or if you want to understand the business use cases. And glossary is also there, data glossary. So generally it is used by our BI engineers, where they would write the column, the purpose of the columns of each tables, and what kind of transformation they are doing. So this actually helped us to get for any new joinee or newcomer to understand the complete flow of the data pipeline. And also DBT has some data quality checks which you can enforce on individual pipelines. So generally we have a data quality implemented on our ingestion pipe on the silver layer, but that is kind of a generic data quality checks. But for use case specific data quality checks, we are using DBT again, where you can write some specific data quality on different tables, and then only uh, 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 proceed with the computation of the pipeline. So, and this is the blog which we have referred. It's a blog which explains you how to connect, or how you can write Hudi. Um, uh, you can create the profile for DBT profile for processing a Hudi table. So basically, you just have to add a setting there, like file format equals to Hudi, and it will DBT will do the incremental upsert or incremental joins on your base tables. This is the design which like downstream pipeline design, where we have CI/CD maintained for our DBT pipelines, where the developer would merge the code to the main branch, and you can basically DBT publish catalog means that you can publish uh, uh, publish your DBT UI, and through that UI you can visualize your data glossary and your data lineage, and then the DBT Docker is built, and Airflow trigger that DBT job. So yeah, so this is the downstream pipeline design which we have followed. And lastly, the impact which we have achieved from after we have migrated our complete data lake into Hudi. So I talk about the availability and consistency. So that has been resolved completely. So right now we don't face any availability or a consistency issues. SLAs has dropped. We have reduced a lot, almost by 70%. So earlier, there were some dashboard reports which we had to refresh on an hourly basis. So that prior to Hudi, the pipelines were not very reliable. So sometimes it would take more than the time we would expect. But now, since it is streamlined, so we have reduced that 30 minutes or the 45 minutes SLA to around 10 minutes. So that is a good achievement for us. And then we have obviously the cost of glue has went down a lot, and we are slowly migrating to EMR serverless. So that is also a cheaper alternative to glue. And again, query performance, as I told you, after we have used the different table services like clustering and cleanup, we have reduced the query performance like drastically by removing Athena from the picture and doing the complete transformation using Hudi and DBT. So yeah, that's I think that's all from my side. I think over to you, Sudha.
Yeah. Thanks for the presentation. I think that was very
Yeah.
useful. I had a couple questions myself.
Hmm.
Maybe are all your source pipelines really like, especially in the context of like the joins towards the
Hmm.
goal tables? Is like, are you depending on the Hudi commit time for the incremental consumption, or like are there other sources that are like
No, right
non-Hudi?
now we are using commit time only.
Okay, got it. Okay, okay.
Yeah.
And
So basically, we have to just check the for the hourly refreshed tables. We have to check the like previous hours. We calculate the what is the previous hour and then compare with that commit time.
makes sense, makes sense. How do you, I think we have a question from Bo. Which Hudi table types are you using?
Right now, we all have all the batch use cases only. So we use COW.
Got it. Okay, got it.
Yeah.
What was, could you help share like how like the observability part of your pipelines? Like, do you how do you set up that and
So.
ensure, since you mentioned like you're using Airflow to orchestrate, if you
Mhm.
can have some details on that, that'd be useful, I think.
So you mean say observability part?
Yeah, yeah.
Yeah, yeah. So basically, we are doing monitoring of pipelines using Airflow only. So we have some Slack integration, and there is another for the tier 1 tables, which are directly impacting the customer-facing use cases. For that, we have integrated two things. So one is the data quality check, which Hudi internally has, and if
Hmm.
that data quality fails, we will via Airflow we have Slack integration, and also there is a tool called PD
Okay,
alerts, which would go and call your on-call engineers.
got it, got it. Okay. We have some more questions on the chat. How are you handling backfilling use cases from Somal?
Backfilling use cases, you mean, okay, can you elaborate on that, Somil?
Yeah, when you have missing data or when particular partitions are corrupted, how are you orchestrating and performing backfilling actions on your fact or dimension tables?
Okay, so in dimension tables, we generally like right now we don't have any mechanism for that. So if suppose if your data fails, we have done save points. So you go back and then reload from that particular point.
Got it.
Got it.
Yeah.
We have more
What
questions
are
from
the
Po. Yeah.
Yeah, so for CDC, we are using we are totally dependent upon AWS DMS. So it's a quite robust tool and it's quite like cost effective also. So right now we are almost handling around 1200 plus tables, both from MongoDB, MySQL, and MS SQL. So all these CDC are coming via AWS DMS. And you have different configurations. You can reduce the file sizes and maybe we can, yeah, I can explain more about that
Mhm.
in the chat.
Yeah, I think there is one more question on async clustering. Does that like
Yeah,
it
yeah,
seems like you're
yeah, yeah,
using.
correct. So yeah, we use async clustering because anyways we don't have any real-time use cases and we don't need to run that clustering job on a daily basis. So right now for few tables, we just do it on a weekly basis. And that actually doesn't impact much on our query performance because in 1 week we don't have that much of data.
Got it. Are there any like does that impact with the right jobs or is there any
Sorry.
conflict with the is the async clustering? I think the question is around. It's also asking around. Does the async clustering conflict with your right jobs? And what do you do to resolve this conflict, if any?
Okay, no, I think we have scheduled it in such a way that it doesn't conflict because generally the conflict will occur when you have some real-time use cases running and you are doing a ingestion as well as you want to do clustering.
Makes
So
sense.
I think that will be the best use case to use async clustering. But in our case, even we don't have, but I decided to use async mode only because it will
Makes sense.
yeah, unnecessarily it will delay your data processing time if we use inline clustering. So that was the thought process.
Got it.
Any best practices we should consider while using DMS? So while using DMS, there are different configurations where you can. So in our batch use cases, we have scheduled a CDC interval to hourly or to more like 6 hours like that, so that the data can be
I think we lost Manish.
Can you guys hear me?
Yes, yes, Siva.
Yeah.
sorry.
Great.
Yeah, I was talking about DMS. So you would use the time interval, which will reduce your number of files, and then also we can also reduce the number of columns if you want. So if you don't want all the columns, you have transformation rules you can apply over there. Then we have something like you can use different compression file types, like gzip would be the best option to use. If you make it default, keep it as none, it will come as a snappy parquet, but gzip would be the better option.
Got you.
Yeah, I have one question.
Yeah.
I'm driving. You might hear some noises. Also, I joined a little late. I'm not sure if you covered this. We are putting in a lot of efforts to try to improve the usability or the time it takes to actually like productionize Hudi. Do you have any
Mhm.
recommendations, for example, from the time you started with Hudi to the time to like doing the staging and then production? What are the things that you felt like could improve on the Hudi side? Like it could be documentation or usability or anything of those sorts.
I think um, uh, at beginning, yeah, definitely we had some problems with the documentation. Not actually documentation, but if you could get some, as a newcomer, if you get some code snippet, like if you see the Apache Airflow documentation, they have a lot of code snippets, uh, and it actually really helps you to do that quickly instead of figuring out everything on your own. So that basically took some time. We have to do some experimentation, and also with Glue, it was the services, especially the async services, was not running with Apache Glue. Sorry, AWS Glue. So that's why we decided to go on to EMR. So yeah, that is a dependency upon AWS side, but yeah, we face that problem.
Makes sense. I think we are prioritizing, at least on the roadmap, we are prioritizing improving the docs. That includes also adding templates or code snippets, but that's on the way. It is
Mm.
still going to come, but I think this is a very useful feedback to help us improve the docs. All right. Any other questions?
One question, Manish, would be
Mm.
if you have some time later on, would you be able to probably write a blog or an article? So that way, any newcomer who's want to learn EMR, DBT, and Hudi, that can serve as a nice guide with code snippets. So, I mean, depending upon your
Yeah,
timeline.
yeah, sure, sure. Yeah, yeah. So, yeah, we actually are planning to write our own Upstox engineering blog. So that will come around like in later half of September next month.
Thank you,
Awesome,
Manish.
awesome. We
Yeah,
can link it from the Hudi website. We usually link all
sure,
the
sure. Yeah,
Hudi
yeah,
usages from the blog for discoverability, but looking forward to that.
yeah. So, yeah, whenever it comes out, maybe in next month, we'll be sharing that.
Awesome. All right. Thank you so much. Thank you,
Yeah,
Manish, for joining us today. And let's meet next month with new set of talks.
sure.
And
Thank you.
this
Thank you,
video
everyone.
recording will be uploaded. Yeah, thank you. Will be uploaded to the Apache Hudi website in a day or two.
Okay. Thank you.
Thank you. Bye bye.